everybody, and welcome to Observatory Nights at the Harvard-Smithsonian Center for Astrophysics. Tonight, we're going to be learning all about America's coast-to-coast total solar eclipse, which will be happening on Monday, August 21st, 2017. Now, let me start by asking those of you who are in this room and in our satellite rooms who are watching to raise your hand if you have seen a total eclipse of the sun. Raise your hand. Nice, a fair number of people. Well, sadly, I am not as lucky as you are. I have never had the pleasure or privilege of seeing a total solar eclipse, at least not yet. But from what I am told, they qualify as a truly awesome sight. As you can imagine, in a total solar eclipse, this is the only time where you're going to see day turn to night. You'll see planets and stars become visible in the middle of the day. And if you look up, you see what almost appears to be a hole in the sky that's surrounded by this milky, ethereal glow. But there's much more to it than that. You can actually see the moon's shadow rushing towards you at 1,000 miles per hour, faster than the speed of sound. You can feel the temperature drop as darkness falls around you. You can even hear the birds and insects grow silent as they return to their nests and burrows. It's an experience that absolutely engulfs all of your senses. It's something that everyone should experience at least once in their lifetimes, and I can assure you that I am going to be taking my own advice next year. Now, the special thing, or the challenging thing sometimes about a total solar eclipse is that if you compare it to a lunar eclipse, a total eclipse of the moon, everybody on an entire half of our planet can see a lunar eclipse. Everyone who's on the same side as the moon can see it. But when it comes to a total solar eclipse, you have to be within a very narrow path on the Earth's surface, the exact location where the moon's shadow will be crossing the Earth. Now, more often than not, that means that you have to travel to some very distant and exotic locations. And so that is one thing that makes this upcoming eclipse so very special. It's going to be happening right here in this country. And it is literally going to be crossing our country from coast to coast, starting up west in the Oregon-Washington area, and then descending and crossing the East Coast in South Carolina, North Carolina. Somebody will have to refresh my memory on that. South Carolina, thank you very much. So, as I said, often you have to travel far to see them, and tonight's speaker has done exactly that. Kelly Beatty from Sky and Telescope magazine has traveled to see 11 total solar eclipses during his lifetime, including 3 that involved being aboard specially chartered planes. In fact, he tells me that the most memorable eclipse that he ever experienced was the one where they flew the plane into Antarctica to intersect the moon's shadow and got to fly over the South Pole twice. So he has had quite the experiences, and I know that he's going to share some of those with us tonight. Kelly has been explaining the science and wonder of astronomy to the public and to audiences of all kinds since 1974. He specializes in planetary science and space exploration as a senior editor at Sky and Telescope magazine. Kelly enjoys sharing his passion for astronomy with a wide spectrum of audiences, from children to professional astronomers, and you'll occasionally hear his interviews and other insights at locations like NPR and the Weather Channel. And he also serves on the board of directors for the International Dark Sky Association. It is my great pleasure to welcome tonight Kelly Beatty.
Thank you. Okay, so first order of business. Let's see if the mic is working. Can you hear me, everybody? All right, good. So Christine gave you a nice summary of what eclipses are all about. Any questions? There was an article in the Boston Globe about a week ago that explored one of the human feelings that we don't often think about, which is awe, A-W-E, awe. And if you think about it, how often in your lives are you truly awestruck? Some of you I know have said that you've been to see a total solar eclipse. You know that that is an awesome experience. Now, how many of you think you might have seen a total solar eclipse, but you're not sure? Anybody? Yeah. Chances are not. The difference between a partial solar eclipse and a total solar eclipse is like having one of those little lame sparklers on the 4th of July and versus going down to the Esplanade and watching, you know, the 1812 Overture and all the fireworks. It's really a very different experience. So we're going to explore that a little bit. And in fact, to get started, what I thought I would do is to give you a sense of what the last total solar eclipse was like, which took place just last March. They happen somewhere on the Earth about every 18 months on average. And so the one last March, crossed the Earth's surface across Indonesia and out over the Pacific. It seems like there's been a really run of total eclipses that have been over the Pacific where they're really challenging to get to. So in this case, the only place to go on land was in Indonesia. And this is typical of some diagrams you're going to see throughout the night. For a total solar eclipse, you have to be between these two lines. The red line is the center, and the outside edges are the limit where the moon will completely cover the sun. Outside of those two lines, you'll see a partial eclipse where the moon almost but not quite covers the sun. So you can see that there were a few islands in Indonesia. This is a time-lapse from a Japanese weather satellite showing the moon shadow literally crossing the Earth. Indonesia is down here. So that's what it looked like for real. Pretty amazing just to watch this loop over and over and over again. Okay, so let's take a few moments to see what some of the sights and sounds of an eclipse are. Here we go. This is a wide-angle view taken from a mountaintop. This is in the middle of the eclipse. So out here where it's glowing, you're out beyond that limit that I was explaining. Up in the sky is that black bullet hole surrounded by this electric white cotton candy. Let's come in a little bit closer. The sun, who knew? The sun has an atmosphere. It's called the corona, meaning crown in Spanish. And the corona shines with its own light, but it's about 1/millionth the brightness of the sun. And so when the sun is completely covered, the corona is visible, and that's the only time it's visible, which is what makes total solar eclipses so special. Now in this picture, you'll notice that it's not just a shapeless blob, it's got some structure to it, and that's because this corona is actually very hot, so that the gases in it are ionized. And because they're ionized, they have to bend to the will of the sun's magnetic field. And so what you're seeing literally is a kind of tracer for the sun's magnetic field. If any of you ever played with iron filings and a magnet in school, that's kind of the same thing that's happening here. Well, this is a time sequence showing the very last little bits leading up to and after the total solar eclipse. And I want you to notice that there are little knots and beads. This is literally the last vestiges of sunlight shining between the valleys on the edge of the moon. Shining through. The phenomenon is called Bailey's beads because Francis Bailey he wasn't the first to see it, but he was the first to really kind of chronicle this effect. This was very interesting. I like this picture because this was taken by an amateur astronomer who was photographing the eclipse. This is the one in March. And he took a polarizing filter and turned it 3 times, took 3 different pictures, and then combined the pictures. So you're looking at the corona's polarized light. This is a really special one. This is the very last bit of sun. Above the surface of the sun that we see as its surface, the photosphere, the light sphere, what gives off all the light, is a very thin layer called the chromosphere. And that shines with this brilliant crimson light, which is indicative of hydrogen. The sun is mostly hydrogen with a little bit of helium. And that hydrogen, when it gives off a characteristic glow, it's this crimson color. This is what we call a prominence. It's an eruption on the surface of the sun. This is far bigger than the Earth right here. In fact, the sun is 109 times the diameter of the Earth. So these are huge, just unimaginably huge features. Now what was really neat about this is that this prominence, this eruption, was right at the sun's, near the sun's north pole. So as the moon crossed and this became visible, it never actually disappeared. It stayed visible through the whole eclipse. It was really terrific. Oh, I love this picture. This is what's called a flash spectrum. And what this photographer took a grating, which is a kind of a prism, and the last little bit of sunlight that was shining here was broken down into its different colors of light. And you can see there's kind of a rainbow going on here, but you see the little lines? These are strong emissions that are characteristic of certain atoms on the sun. So I just told you about this crimson light over here. That's from hydrogen. These two are from hydrogen as well. These are different emissions from hydrogen gas that tell scientists what the composition is. So this is the way we dissect starlight. We can take the light from a star, break it into its spectrum, and if you see strong emissions like this, it's telling us what the composition of that star is. Across thousands or millions of light years, we know what that star is made of by breaking down its light. There's two more here I want to tell you about. This orange one right here is from helium. Now, helium was actually discovered in the sun by an eclipse. Astronomers looked at a spectrum, saw this orange line which didn't correspond to anything they knew about in the laboratory, and they called it coronium. You get the picture here because it was only visible when the corona was out. And we later knew that it was actually from helium that's in the sun. And there's one more here, this green one that I want to tell you about that's really kind of special. See that faint green one? That's from iron atoms. And the only way that the iron atom can give off that particular green light is if its atom has been stripped of 13 of its electrons. In order to have 13 electrons stripped, it has to be at a temperature of about 2 million degrees Fahrenheit, 1 million degrees Celsius. So that little tiny green line is telling you that this is from gas that's been heated to a temperature of millions of degrees. Pretty special, I think. All right, so this is fun. A friend of mine who's a meteorologist for this eclipse realized that there was a scheduled airline flight on Alaska Air, Flight 870, that was going to fly from Anchorage to Honolulu on the day of the eclipse and would be crossing very near the path almost exactly at the right time. And in addition, the sun would be low enough to the horizon to be seen in eclipse out the window. So 18 months in advance of the eclipse, he contacted Alaskan Airlines and said, hey, I'm here to tell you that you have a really great opportunity here. And nothing happened. Nothing happened. You know, airlines, they got to keep that schedule. And he kept knocking at their door, and finally they got into the game. And on Eclipse Day, not only, they made a big deal of it. It's like a documentary films were taken. They had a brand new plane with super clean windows. They had a second plane. They had a second plane standing by in case there was a problem. It was quite a successful trip, as you can see. And what's really neat about this is you get a sense for the moon's shadow below the plane racing across this is out over the middle of the Pacific. Okay, so what I want to show you now, enough of me talking. I want you to listen to this. This was taped in Micronesia during the eclipse. What's going on here is that the camera has a filter over it. This is the last little edge of the sun that's about to disappear behind the moon. The moon's moving from right to left. Just listen.
We're anticipating a diamond ring.
Oh, a tiny little sliver. Oh, it's really getting dark.
Here we go.
Here comes the shadow.
Close.
Diamond ring! There it is.
Diamond ring, that's it.
Great.
Oh my goodness. That is the most beautiful thing.
Now the filter's been taken off.
Now we see the streamers.
Oh,
They're reaching out into the sky.
the corona is so nice.
Hear the
Look at
cheering?
lines.
We're getting a
Could be
really
you.
strong streamer on the lower
See the prominence up here?
left-hand side.
Oh, wow.
It's absolutely gorgeous. I'm seeing stars. I believe I see Regulus.
Oh, yeah. So that's Venus and Mercury.
Venus and Mercury. We're not seeing other stars right now, but we are seeing Venus and Mercury.
Yeah, the sky has gone dark. It's like night coming on. And the clouds around the horizon are dimly lit with yellowish brown. It's the sunlight's still hitting the distant clouds. Oh,
It is.
it's dark here.
I see birds flying overhead. Actually, a lot of birds
Yeah.
have come out of the trees and they're circling.
Oh, and that prominence sticking up into the corona.
That's unbelievable.
It's just gorgeous. What a great set of cameras.
Absolutely gorgeous. If I put on my eclipse glasses, I cannot see a thing. We're all looking with our naked eyes. Crowd is sort of quiet. I think they might be a little odd. I know I am.
It's amazing. And my eyes are adapting to the dark, so I'm seeing more and more detail in the corona.
I can
They're-
actually see the pink prominence.
Yeah, and the corona is reaching out more than one solar diameter. And in particular, I think there's a helmet streamer. It's like a World War I helmet.
Right, so we call that helmet, they're sort of long and pointed.
That's right.
It really stands out. And again, Venus and Mercury are...
Asia.
That's right. They have some ground-based observatories, including the National Solar
Oh,
Observatory.
here comes
Here we
the
go,
diamond ring.
Okay. When
Diamond ring.
people need to put their glasses
Time to
on.
put your glasses on.
Glasses? Glasses? Okay, the light is coming back. My goodness, that's so fast. All of a
Oh, yeah.
sudden, everything's lightening up just with that tiny, tiny bit of sun.
I can still see Venus.
I have a friend who once said that no matter how long a total eclipse actually lasts, it only seems like it lasts 7 seconds. Did that seem like a 3-minute video to you? And I cut some of it out. She said it, it's not just an experience, it is an awesome, awesome experience. This is actually a funny little cartoon created by Bill Kramer, who's one of the world's most accomplished eclipse chasers. So that's a little nod to him. All right, let's get into why eclipses happen. Eclipses, you might be, like I have been in the past, confused between solar eclipse, lunar eclipse. Lunar eclipses cover the moon, solar eclipses cover the sun. Lunar eclipses happen at full moon, and so like here is the moon going through the Earth's shadow at what would otherwise be full moon. And solar eclipses happen when the moon comes directly between the Earth and the sun. So one happens at full moon, the other happens at new moon. Why then, I know you're asking, don't we have eclipses every month? Right? And the answer is that the moon's orbit is not exactly in the same plane as Earth's orbit around the sun. It's tipped by just 5 degrees. And so consequently, an eclipse can only happen when the line of that intersection of our orbit and the moon's orbit is pointed toward the sun, and the moon is in the right spot when that happens. So eclipses can only happen at these 6-month apart intervals, and only when the moon happens to be right where it should be when that crossing happens. Now, lunar eclipses, I just want to draw a distinction. As Christine said, a lunar eclipse can be seen whenever you're on the back side, the night side of the Earth. It's when the moon goes through the deepest part of Earth's shadow, the umbra. You'll sometimes hear these called blood moon eclipses. The last one was in September of 2015, September of last year. And the reason is that light leaking past the edge of the Earth, going through sunsets, sunset's red light kind of leaks by refraction through our atmosphere and casts a kind of glow on the moon's surface. And so you end up with something that looks like this, with this kind of coppery color, and it's terrific. Now, an eclipse of the sun, it involves the moon itself. This is an animation by NASA, and this is actually to scale. The Earth and moon are to scale, and so the moon's shadow is to scale, right? And so I want you to notice it's going to whip around. That's when it's not in the right location, but over time, when it gets to that nodal crossing, it can cast its shadow on the Earth. And you notice that it's just a very tiny dot on the Earth's surface. Okay? Time for audience participation. Everyone stick out your fist, don't hit anybody, and hold up your pinky. And look at that pinky fingernail. That fingernail is about 1/2 degree across. Now that will very neatly cover the moon or the sun. I don't recommend the sun, but it will cover the moon or the sun in the sky. They're both about 1/2 degree across. Isn't it remarkable that the sun is 400 times the diameter of our Earth, of the moon, but it's 400 times farther away? So in the sky, they have just almost exactly the same apparent diameter, and so consequently, when the moon covers the sun, it's just barely able to do so most of the time. The problem is that the moon's orbit is not perfectly circular. It's a little bit elliptical, as we say in the astronomy biz. And you've heard the term supermoon. You've maybe heard it within the last week. Actually, we at Sky and Telescope, we hate that word, supermoon. But I will tell you that in November, because you heard it here first, there'll be a supermoon in November when not only will the moon be closest to Earth at the time of full moon, but it will be the closest that it's been to the Earth since 1976, and it won't be this close again for, I think, until 2030. In any case, as you might imagine, when the moon is closest to Earth, it's a little bit easier for it to cover the sun. And when it's farther away, and it's not big a difference, it's like, you know, you can see these are the extremes. But when the moon is farther away, it just barely cannot cover the sun completely, even though it's going straight across it. We call that an annular or ring eclipse. And this is what the two of them look like in the sky. In a sense, an annular eclipse is a special case of a partial solar eclipse because not all of the sun is covered. There was, some of you probably remember, there was an annular eclipse not far from here in 1994. It went through southern New Hampshire. Did any of you see that? A few of you? Yeah, that's great. It is a fun event too. This is what the sequence of an annular eclipse looks like. It's a very geometric kind of thing. Well, all right, so when the moon casts its shadow on the Earth, it just covers a small part of the Earth at any one time, no more than about 120 miles across. But around that is the area where you will see a partial eclipse. So you saw that animation before. Here's another still picture taken from a Russian space station in 1999 over Europe. And the dark core here is where the moon is completely covering the sun. And you can see that it's kind of dusky all around. And the closer you get, the more of the sun that's covered. So that's the partial eclipse. Now, as the moon moves through its orbit, it gradually crosses in front of the sun and then leaves. That whole process from the very beginning of the solar eclipse up here till down here takes about 3 hours, 3.5 hours. But the total eclipse itself is much shorter. The maximum amount of time that a total eclipse can last is just about 7 minutes. And it actually did that in 1991. And in 2009, was an eclipse over the Pacific that lasted 6 minutes and 39 seconds. That's the longest eclipse there will be in the 21st century. It's all downhill from there. Okay, so this is, I mentioned that eclipses can happen anywhere on the Earth, and Christine alluded to that too. The red tracks here are annular eclipses, and the blue ones are total eclipses. And so that one that just happened, for example, in Indonesia, that's this track right here. And so here's our track for 2017 going across the United States. Seems kind of random, doesn't it? But let's home in on it. This is for 20 years worth of eclipses. Let's expand it to 25 years and get rid of the annular eclipses. And now let's look. And now you can see that there's a pattern here. This one certainly looks like this one. This little S-shaped curve looks like this one, and so forth. There is a pattern here, and that pattern has a name. It's called a Saros cycle. And it turns out that geometrically, every 18 years, 11 days, and 8 hours, the Earth, Moon, and Sun all return to the same relative geometry in space. And so you get circumstances for an eclipse that are very similar. And so you can see here is an eclipse that took place in 2009. 18 years later is 2027, and here's 2045. It's this 8 hours that is causing these curves to be offset, because in 8 hours, the Earth turns about a third of the way around. So even though in an absolute sense, the eclipse is happening in the same place in space, the Earth has turned. And so you get a pattern that repeats. And if you notice, though, there is a kind of super pattern going on here. Okay, so this Saros cycle is made up of hundreds of eclipses that occur in kind of a family. Think of them as a family of eclipses that take place over, over more than 1,000 years. And at any given time, any given stretch of time like that map I was showing you, there are many Saros cycles happening in an overlapping fashion. So 2 eclipses in a row are not in the same Saros cycles. There's one from here and one from here, right? They are, they're actually in a sequence, and you notice that there's a progression here. This is making a march toward the North Pole. These are all making a march toward the North Pole in time. And this is what one of those Saros, 2 Saros families look like. They start off with partial eclipses in the poles, maybe the North Pole, maybe the South Pole, either way. And then they gradually migrate in latitude across the equator, and they always include some combination of total and partial eclipses. So these are 2 Saros cycles shown together, all right? So this cyclic nature of eclipses was known to many ancient cultures. We sometimes think that the Chinese were good at this, but actually it was the Babylonians, beginning about 300 BC, that cracked the code. They deciphered that there was a Saros cycle, but they didn't understand why the eclipses weren't happening where they were every 18 years, and the reason was this 8-hour shift, right? So if they lived long enough, they would eventually see it again. So this was a really dramatic breakthrough for these ancient cultures to have the math to be able to sort this out. And it turns out that these supercycles of 3 Saroses every 54 years and 34 days, not only does the geometry repeat, but the Earth has gone through those 8-hour cycles, and you literally get an eclipse almost exactly in the same place as it was before. So here's 1901, and 54 years later, 55, and 54 years later, 2009. There's actually a name for this sort of supercycle, and it's called exeligmos. Will you say that with me, please? Exeligmos, right, that's your word for the day. It's like one of those Harry Potter spells, Exeligmos. So, turns out that the ancient Europeans had a machine that could be cranked through to predict these Saros cycles. It was dredged up from the Mediterranean not that long ago, and this is a recreation of it. You can see the crank here, and they could use this to actually predict the eclipses. So, we've been able to predict eclipses for quite some time. It turns out that it's statistically the case that any place on the Earth's surface over the course of 375 years will see a total solar eclipse. Actually, that's not strictly true. Right now, there's a slight bias for geometric reasons for the northern hemisphere against the southern hemisphere. So we get them a little bit more frequently than that. So I asked a friend of mine to plot all of the total solar eclipse paths over the United States from 1775 until the year 2050. And this is what we get. You notice there are some holes down here. A few here, right? We here in Massachusetts, we're well covered. In fact, here's a path. I should find out what year this is. There's 2 of them that go right over us. That's terrific. So let's take it a little bit further. Let's make it 1,000 years. Even in 1,000 years, there are still a couple of places, right? Down here in parts of I thought there was a place in West Texas that was still missing some, but it's pretty much covered. So in 1,000 years, if you live long enough, you'll get to see an eclipse no matter where you are. What I'd like to do now is highlight for you 3 important eclipses in American history. Let's start with 1878. In 1878, there's the track. It went across the U.S. Remember, by this point, we had a railroad across the country, so you could actually get to that eclipse path from the East Coast. And what was really in the news back then was the hunt for a planet called Vulcan. And the reason that was supposed to be very close to the sun, closer to the sun than the orbit of Mercury. And here's why. This is the orbit of Mercury. It goes around the sun every 88 days. And it has, you notice it's not a circular orbit, it's elliptical. It's actually quite strongly elliptical. And astronomers watching Mercury over time had noticed that the shape of Mercury's orbit was gradually shifting, what we call precession in astronomy, very slowly, only 0.2 of a degree per century. That's not very fast. But the point is that the laws of physics didn't allow that to happen. There had to be something else in play, and astronomers imagined that there must be another planet even closer to the sun than Mercury that was tugging on Mercury and causing its orbit to perturb like that. So the only way to see very close to the sun is during a solar eclipse. And so a team of astronomers made their way out to Wyoming on the railroad. This is the path of that eclipse. It actually went right over Denver and Fort Worth, Texas. And they camped out here in western Wyoming. It was quite an interesting, one might say, motley crew, but they were all wearing their finest, except this guy here. He seems a little, you know, Jack Kerouac-y or something. That's Thomas Edison. And in fact, he had, this is in 1878, he had invented the phonograph, but hadn't quite invented the incandescent light bulb or perfected it. So this is that group. I have a bunch of pictures here. This is a group of astronomers near Fort Worth, Texas. And I want to point out that the garb certainly gives them away. Straw hats. Not too many of my astronomy friends wear straw hats anymore. But we would be perfectly comfortable using these telescopes. We would know exactly what to do. The technology of telescopes, refractors in any case, hasn't changed much. Some of you might know, if you've been to Nantucket, that there's an observatory there called Maria Mitchell Observatory, started by a woman, Maria Mitchell, who was one of the first American women to get a formal education in astronomy. And after she established this observatory on Nantucket for women. And so she took a team of 5 of her young ladies out to the Denver area, set up telescopes to watch the eclipse. It was a big deal in 1878. It was making all the news. You know, there were a lot of tabloids. This is Harper's Weekly, which was a very prominent publication in that time. Let's fast forward to June of 2018. This is the last time, the previous time, it's been 100 years since an eclipse has gone coast to coast across the United States. And so this is that track. Interestingly enough, the one coming up next year will be the first eclipse since the Revolutionary War era that has its only landfall will be on the United States. This one barely eclipsed the Bahamas, so it doesn't count. But this was the last time a total eclipse went coast to coast. A lot of the astronomers were in the Northwest in Oregon. This is a painting at the time showing the corona. This should be starting to look familiar to you now. This is a photograph. Photography had come into vogue. You can see a lot of the familiar features. There are those prominences. They showed up quite nicely. This was from a team from Lick Observatory. 1925 is the third one I want to mention to you. You can see from the map that the track didn't spend a lot of time over the United States, U.S. Most of it was out over the Atlantic Ocean. Here's the portion that was across the U.S., so there was not much landfall, but it went right over New York City in January, all right? And so this was a big deal in New York City at the time. At that time, the main mode of transportation was by railroad, so the local railroad companies put out eclipse pamphlets. This is a picture of a political operative at that time, William Jennings Bryan. He's looking through some kind, it looks like film to dim the sun. It was quite the spectacle. They actually closed the New York stock market for 45 minutes during the middle of the eclipse so that everyone could go out and see it. Photographers for the Edison Company, what is now Con Edison, were out in force. The Army, the Navy, excuse me, even dispatched one of its dirigibles over downtown New York in case it was cloudy down at ground level. There were squadrons of fighter planes in the air with a pilot in the front and an astronomer in back, you know, to make sure that everything was captured. A little bit closer to home, this is Seagrave Observatory down in outside of Providence in North Scituate, and the astronomers there were taking pictures. This is a lovely sequence showing the partial phases leading up to totality in the sky. Not bad for that time. Now, in Washington, D.C., the eclipse was not total, but it was a deep partial eclipse. And so President Calvin Coolidge and his entourage, his family, were out looking at the partial eclipse. Now, we'll have some fun. President Obama has hosted 2 star parties at the White House during his 8 years in office, with telescopes and the whole shebang. He is not the president who has spent the most time doing astronomy at the White House. Who thinks they know who that president was? Any guesses?
Thomas Jefferson.
Thomas Jefferson would be an excellent guess, because we know that Jefferson owned a telescope. It's on display at Monticello, but he did not take it with him to the White House. Yes?
I think it might have been Theodore Roosevelt.
Theodore Roosevelt. And why do you think that?
Because he spent a lot of time looking at the sky.
He spent a lot of time looking at the sky. Well, anybody from upstairs want to guess? I will tell you who it is, and you probably would not have guessed it. Jimmy Carter. And do you know why? Because you might remember Jimmy Carter had some children in the White House, and his son Chip, as a teenager, had an 8-inch Celestron telescope that he routinely carried to the top of the White House roof and went stargazing from there. And he invited the family up to do that with him. So there you go, for your next party. Okay, let's talk about our eclipse next year. Here's the track across the United States. It starts off in Oregon and ends up in South Carolina, traveling at a roughly 1,500 to 1,800 miles per hour as it crosses the country. There's the track. You see these other bands show the proportion of the sun's diameter that will be covered to either side. That day, everyone in North America will see a deep partial eclipse. Here in New England, we'll see the sun about 70% covered. And these times are universal time. It will take the moon's shadow about 90 minutes to cross. These bands are at 30 minutes apart. It will take about 90 minutes to go from one side of the US to the other. So let's take a look at this in some detail. Here's a little bit better shot. We can show you that the maximum totality you'll have is about 2 minutes and 40 seconds, which won't be very long, but it will certainly be plenty enough to satisfy you if you happen to go. Let's start in the northwest. The track is only about 70 miles wide, and so it starts Salem, Oregon is in the path. The thing about the west coast, and we'll see this later when I talk about the weather, there are mountain ranges on the west coast that, the moist air is coming in off the Pacific. The coastal ranges are not really tall enough, but the Cascades here are plenty tall enough to sort of wring the water out of the moisture out of the air. So we're expecting this area in here to be pretty clear. Western Wyoming, including Jackson and the Tetons. So let me just show you some of the pictures. These are the places you could be watching the eclipse. John Day Fossil Bed is a beautiful site in eastern Oregon. The Snake River Plain in Idaho would be a great place to look. Christine showed you this is where the Smithsonian Journeys tour is going to go in Grand Tetons. Unfortunately, the sun will be over here instead of over there, so you won't be able to get them both in the same picture, but it's breathtaking scenery nonetheless. Okay, in the nation's midsection, the path goes right over Caspar, Wyoming, through the heartland of Nebraska. It goes St. Joseph, Missouri. Kansas City is just barely skirted. Columbia, Missouri, lots of Missouri, and here's Fort Caspar in Wyoming. That's the correct spelling for the fort, not the city. An interesting place. How many of you have ever been to Caspar? Okay, great. It's not high on the list of tourist attractions, but it'll be popular on Eclipse Day. To the southeast of Caspar, is the tiny little town of Glendo, Wyoming, population 205. That's where I'll be, or Peter will be, with our Sky and Telescope group. This little town is expecting, they're really all over this, they're expecting somewhere between 50 and 75,000 people on Eclipse Day. They have already ordered every porta potty in the state of Wyoming. Interestingly, I went to visit there with my wife this past May. They have a school there. It's a K through 12 school with 50 students only. K through 12, 50 students, and yet they have a permanent observatory on their schoolyard with a telescope inside and horses grazing in the back. So that's fun. Elsewhere, Sand Hills, Nebraska, beautiful. There's a lot of beautiful rolling countryside there. Nebraska's wide open. Can you imagine seeing a total solar eclipse with Mount Rushmore in the background? Not going to happen. It's not in the path. But Carhenge is. This is a real place. It's in Alliance, Nebraska. It's a recreation of Stonehenge using actual cars that have been stuck in the ground and painted gray. And they are planning quite a party on Eclipse Day there. Okay, the third half is St. Louis is just barely within the path. Nashville's in the path. Columbia, South Carolina is in the path. There's a lot of terrific real estate along here. And I want to point out that the eclipse will be its maximum well, it depends. There's kind of a fight going on. The people in Hopkinsville, Kentucky, which is where one of the Sky and Telescope tours will be, claim that they will get to see the greatest eclipse. And that means that the Earth and Moon and Sun will be, their centers will be most aligned right there. But the good folks of Carbondale, Illinois say, no, 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 no. Because of the irregularities of the Moon's edge, the eclipse will actually last 0.2 of a second longer for us. So we have the bragging rights. And so Carbondale actually also happens to be a place where only 7 years later, another total eclipse path will cross. So this is like the ultimate observing location. And I have to say that the people of Carbondale have spared no expense getting their town ready for the eclipse. It's cloudy, yes it is. Anyway, this is the center line right there. Nashville, Tennessee is in the path, as I mentioned, of the Blue Ridge Mountains, some really pretty territory. So from coast to coast, there's all kinds of places where you could go to see this eclipse. But climatologically, not every place is created equally. This is a satellite weather photo taken in 2015, last year, 2 years before the eclipse. And you can see the path goes, here's the path going through a little bit higher. And it's really nice and clear out here in the west. I don't have the eastern part. Here is this past August 21st. And this is a little loop. And you can see, again, it's very clear. And we would all be seeing the eclipse there. If I were in Nashville, Peter, it would not be so nice. Because look at the bands of clouds here, right? So on this particular day, it would not have been so great. So let's take a look at the actual science here. These are averages for the amount of cloudiness in August, the whole month of August, for 7 a.m. in the morning nationwide. On this plot, blue is great. Red is, I wish I had picked someplace else. And you can see that the western half of the track is indeed favored. But now, what I want you to remember is that it's taking, not only is it taking the moon's shadow 90 minutes to cross, but because of time zone differences, the eclipse will start at about 10 a.m. in Salem, Oregon, Pacific time, and end about 3 p.m. Eastern time in South Carolina. So let's look at the statistics for the afternoon. This is at 2 p.m. in the afternoon. It's still similar, except right here in the Rockies, there's a cloud buildup. Let's flick between those. You can see that the difference between the morning and afternoon is kind of significant over the Rockies. Fortunately, the Rockies, for them, the eclipse happens just before noon. So the morning times are probably the better. Okay, so but the good news is that all along the path, you have at least about a 50% chance of having clear skies on eclipse day. So, I'll tell you something. Christine was telling you that I've been all over the world. And people often go to see eclipses because they've always wanted to go the place where the eclipse is happening, right? Whether it be Africa or Hawaii or, Scotland or someplace interesting, China. That way, and people say, oh, I've always wanted to go to China. Oh, there's an eclipse. Let's use that as an excuse. That way, in case you don't see the eclipse, I've been clouded out 3 times. In fact, 3 years ago, I led a sky and telescope tour with 40 hardy individuals to Kenya. And we had a great time in Kenya. We saw a lot of safaris. We flew on private planes to the shore of Lake Turkana. And if you've never heard of Lake Turkana, there's a good reason. It is out in the middle of nowhere, dirt landing strips, dust blowing all over the place. In fact, we had a dust storm. There was nothing there, except we were on the path of totality. For 11 seconds of totality, we flew halfway around the world. It was cloudy. So, if you go someplace to look for an eclipse next year, make sure it's a place where you can have fun. I mentioned Caspar earlier. Caspar is one of these towns that has really kind of rolled out the red carpet. They're embracing this eclipse. They're putting on a 3-day festival. A national organization called the Astronomical League is having their annual meeting there. The place is going to be crawling with astronomers. But that's a good thing in case you have trouble with your equipment. The thing about Caspar is it's pretty crowded. Listen.
1st, 2017, and Caspar is one of the few places in the world where it will be a total solar eclipse. Caspar has been gearing up for this event for several months now. The eclipse has the potential to double the city's population for the event.
So it's come to Caspar for a wild outdoor weekend and, you know, satisfy your need to be outside and breathe the air and do fun things. And so that's really our strategy for in the state of Wyoming.
9 hotels are already sold out for the event, and another 6 are not accepting reservations.
This aired back in May. And I'm here to tell you that the hotels really are sold out. But don't fear, because you don't need to be staying in a hotel in the path of the eclipse in order to enjoy it. If I were you right now and you didn't have the money to either join the Smithsonian tour or ours and you wanted to go it alone, my recommendation to you would be to fly to St. Louis, rent a car, and drive west until you found yourself in the path of the eclipse. You can do it, you could literally do it in a day, right? It doesn't have to be a big deal. So there are a lot of places where you can actually see the eclipse quite easily. Okay, let's talk a little bit about how to view the eclipse safely. Thank you. Now, it's true that the moment when the sun is completely covered by the moon, you do not need any kind of special filtering, right? It's perfectly safe to look at the corona of the sun. Any other time before or after, danger, danger, danger. And that includes if you happen to be here for that eclipse, you are going to need to have a safe, approved solar filter. These are essential during the partial phases. You might see things on the internet about wearing sunglasses or Pop-Tart wrappers. Please don't. Because the problem is that they might block the visible light, but what really is going to literally cook your retina is the infrared light in the sun's rays. So you don't want to use that. And again, you do not need to use them during totality itself. These filters are specially made to block all but a very small amount of the sun's light. This applies either for your eyes or your glasses. This is what they look like. I need a volunteer. Would you like to help me? Yeah, come on, stand and put these on. All right? Okay, now face me. Right? How many fingers am I holding up? Am I holding up fingers?
Not even going on. Yeah.
Just hold them on your face.
There you go. Right? Can you see anything at all?
No.
All right, walk in that direction about 20 feet. Thank you.
Hit a wall.
Yeah, you would rather. So these are like super, super dark. They come in this size. Actually, we at Sky and Telescope, we're going to break the mold here. We're going to use this version, which it's got the filter material right here. And you can put it on a string and hang it around your neck and just have it ready to go at a moment's notice. It happens to work really well if you wear glasses like I do. I can't see these spotlights. It's that dark. So proper filter is very important no matter what style and shape you use. Make sure your pets are protected as well. No, seriously, this approved solar. And when it comes eclipse time, the market will be flooded with inexpensive solar filters. I actually know that some major U.S. retailers are planning to give them away. I'm not at liberty to say. But I want to close by talking a little bit about the science that can be accomplished during a solar eclipse. And we're going to talk a little bit about the sun itself. It's not showing up very well with this projector, but the sun's energy is generated in its core, which has a temperature of about 16 to 18 million degrees Fahrenheit, Kelvin. That's 27 million degrees Fahrenheit. And that energy is caused by the conversion of hydrogen into helium, a process called fusion. The sun is mostly hydrogen. If any of you ever taken astronomy class or have taken one, let me just tell you that if the professor asks the question and you don't know what the answer is, if you answer hydrogen, you have a better than even chance of being right, because the universe is made of hydrogen. Anyway, that energy eventually makes its way out to the photosphere, which is where the surface is, and the photosphere has a temperature of about 11,000 degrees Fahrenheit. Plenty hot, plenty hot. The problem is, however, that while the photosphere has a temperature of 11,000 degrees, the corona just above it has a temperature, remember I said, a couple of million degrees. We don't fully understand why that process happens. Something happens between the surface of the sun and out here, and the problem is we have spacecraft that study this part of the corona, and we have other spacecraft that study the surface of the sun, including the Solar Dynamics Observatory, and the Center for Astrophysics applied some of the key camera experiment on that. Look that up sometime. I think it's called The Sun Now on the web, and you can see the terrific pictures that are being radioed back from orbit. However, it's this inner corona that we have trouble seeing except during total eclipses of the sun. And so some astronomers from the National Solar Observatory are planning, remember I mentioned that the eclipse will run for 90 minutes across the United States. Now, remember I showed you that map of all the weird places that eclipses run, right? Eclipses can be seen. Imagine we're going to be crossing the United States with all of our technology and wireless connections, tens, if not hundreds of thousands of amateur astronomers all along that path. It's a great time to be doing science from beginning to end. And so these astronomers are going to set up something called Project Citizen CATE. They're going to equip professional astronomers teamed up with a student, high school student, college student, at 60 locations along the eclipse path. There is the prototype of the equipment. There's all the little pins. They're raising money right now. Citizen CATE is the project. The green ones are ones for where they have funding. You can see all these interesting places. Not all of them are exotic, however. Like one of the Citizen CATE locations is this gas station in Stanley, Idaho. However, it could be a really fun experience. And the great thing about this project, as they've designed it, once the eclipse is over, the students get to take the telescope and the equipment back to their school. So I think that's really great. A second one is from the Montana State University, which has a real history of balloon-borne science. So they're going to do kind of the same thing. They're going to have balloons all along the path that they will have cameras on, launch them up to great, tremendous altitudes, and they'll return pictures like this. This is a balloon photograph during an eclipse in 2012. And you can see there's the eclipsed sun. Here's the moon's shadow looming on the ground below. Here's the shot in the other direction, away from the shadow as it trails back. It could be very terrific if they get that to work. Now, the one that I find most fascinating is this. Chrissy mentioned that during totality, the sky gets dark and the brightest stars and planets show up. You can see them by eye. During next year's eclipse, Jupiter and Venus will both be in the sky near the sun. They will be slam dunk easy to see. Mercury and Mars will be nearby. There are some other bright stars. Sirius should be pretty obvious to see. It's possible to see stars during the eclipse. And one astronomer, an amateur astronomer out in San Diego, has an idea. He is going to try to recreate the experiment that proved that Einstein's general theory of relativity was correct. Remember the problem with Vulcan, right? The planet near Mercury that was causing the Mercury's orbit to precess? Well, there was no Vulcan, but there was general relativity. It is general relativity, relativistic effects, the warping of space-time near the sun by the sun's gravity that caused that perturbation on Mercury's orbit. And so what this amateur hopes to do is measure the bending of starlight near the sun. Now, it's not very much. You might not be familiar with arc seconds. That's how much we're talking about. An arc second is the diameter of a penny as seen from here if somebody holds it up in the window of the top of the Prue. Okay, that's 1 arc second. And that's the maximum amount of bending that will take place in that starlight. So this is the guy, Don Bruns. That's his equipment. It doesn't look all that exotic. This is standard off-the-shelf amateur astronomy equipment. And what he plans to do is the closer he gets to the sun, distance from the sun, these are diameters of the sun, the more the star's light should be bent. He completely expects to be able to do this. And it could be very, very exciting for him if he's able to accomplish it. He's been practicing for years. He had an article about that in the August 2016 issue of Sky and Telescope if you want to check that out. Okay, I'm at the end. You know, the thing is that there are plenty of resources already online that can help you. If you have a cell phone camera and you want to snap a picture of that, this would be a good time to do it, or you can just play this back. It's going to be streamed. This lecture will be streaming later. And a lot of these places are really terrific. Of course, skyandtelescope.com/2017-eclipse is a place where we have a portal to, and we can lead you to lots of great resources, where to find glasses, where to find equipment, and so forth. This is a fun one. I encourage you. This is kind of a long URL, but if you just Google 2017 Eclipse Xavier, this site will come up. It's kind of like a Google map, but it's interactive, and you can zoom in along the eclipse path, and if you click on a spot, it will tell you what the circumstances of the eclipse are for that spot, how long totality will last, how partial it is, where the sun will be in the sky, and so forth. So it's really, there are plenty of resources. NASA has its own site up now, and so forth. So the only question remaining is, where will you be when the moon shadow crosses on the 21st of August of next year? Christine mentioned that it will be a Monday. Why don't you plan to take that day off? Thank you very much.
Questions for this very knowledgeable gentleman? Yes?
Spectrum from the sun. Are you talking about different forms of hydrogen? You seem to indicate there are different forms of hydrogen showing up in that spectrum.
Okay, so the question is, in the spectrum, in the flash spectrum I showed, it seemed like I was talking, the different lines were for different forms of hydrogen. No, they're all the same. The hydrogen atom, simple as it is, has a series of, an atom gives off light when an electron gets to an excited state and then returns to a less excited state. Well, there are many levels in that simple atom, and so it's called the Balmer series of emission lines. Hydrogen alpha is the crimson one, hydrogen beta is the blue one. There's a whole series. It's just one simple atom. Great question, though. Oh, come on, let's try to stump the astronomer. Go ahead.
What's the state of solar activity at the time of this eclipse, and how large would that corona be?
Right. I expect the sun will still be shining. The question is, what's the state of solar activity during the eclipse? We'll actually be close to solar minimum. And at solar minimum, you've seen plenty of eclipses. What does the corona look like at solar minimum?
Small.
Yeah, no, it's actually it's its shape, not. All right, at solar minimum, the corona tends to be actually longer in the equator and shorter at its poles. When we're at solar maximum, it tends to be more generally round because the solar wind is fast up at the pole. So it will be at solar minimum, and in fact, solar coronas are a little bit like fingerprints or snowflakes. They're all different, and you can recognize them if you get into this game. I have to say, we have a saying. I've been to many eclipses, and for those of you who've not seen one before, I would wager that the first 4 words you will say after you see your first total solar eclipse are, when's the next one? Because they are truly habit forming. I'm here to tell you that the one after 2017 Goes over right over Chile in South America. If you've ever wanted to see the southern sky. Peter, do you think we'll have a tour to South America for that eclipse? I can bet that. So anyway, South America, 2019. Yes?
Is the corona change rapid enough to see a difference from one side of the country to the other?
So the question is, will the corona change rapidly enough to see from one side of the country to the other? That is the expectation, right? That's why they're setting up this long baseline so that they can literally get a continuous recording with the same equipment. That's important, right? All along the eclipse path, right? Can you imagine a corona, an eclipse that lasts for 90 minutes? It's been tried. Some of you might remember the SST, the Concorde, from the 1970s. One of them was outfitted with special windows and camera to chase a solar eclipse in the 1970s. It didn't quite keep up with the sun, but it was enough to have an hour of totality as seen from that plane. But our detectors are much, much better now. So we expect to be able to actually see those changes in the corona as they are happening. That's the beauty of this citizen CATE experiment. It's a really terrific experiment. Do you want to lead the questions, or I'll just in the back? Go ahead. I'll get upstairs if any of you have questions next.
How long looking at the sun without the filter would it take before somebody's retina got cooked?
Yeah, great question. And I'll give you my personal recommendation. How long can you stare at the sun without a filter before your retina gets cooked? You would have to really work at it. It's many seconds. And the reality is that your blink reflex, looking at the sun, forces you to shut your eyes far before damage can occur. Okay? I don't want you looking at the sun, but the practical reality is your eyes will probably kick in. The people that have experienced eye damage, and there have been a few, these are people who go out and do this. Please don't put that on the internet. Too late. So you have to really be intentionally stupid in order to do eye damage. Great question. Go ahead.
What kind of equipment will you be bringing to the eclipse?
Very good question. What kind of equipment will I be bringing to the eclipse? I will be in charge of a group of people, so I'm going to keep a light load. But if I were there by myself, I like to go light. I do not do photography during the eclipse, and in fact, this is a strong recommendation to you. If you do go to the eclipse, and if you want to take photos through a telescope, don't. Because it's not easy to do. What I would suggest is take a video camera, a GoPro or something like that, and just mount it on a tripod with a wide angle, including the sun and the horizon, and because you're going to be doing this in the middle of the eclipse, and you want to capture that. So I would, if I were bringing equipment at all, I would bring either a pair of binoculars or a small telescope. You don't need a drive or any kind of fancy electronics. If you've got a small telescope at home, that would be plenty good. Now remember that those optics need to be protected with filters if you're looking at times other than totality, right? So make sure that you have a filter that will fit over the end snugly, and importantly, that you can flip on and off quickly without disturbing your mount. So I'm going to be taking it pretty easy. I'll tell you a story. In 2000, when did we go to Spain? 2004, 3. My wife and I went to see an annular eclipse in Spain, not far from Madrid, and I had two things with me. I had a rollerboard suitcase, and I had a backpack. We were there for a week. The rollerboard suitcase was my equipment. I had the telescope all broken down into pieces, and it fit in there. My clothes for a week were on my back. Yeah. And it was a terrific experience, and there wasn't anything particularly complicated about what I brought. It's just a simple telescope. Plenty of telescopes these days can be put in an overhead, and some are made especially for portability. Anybody upstairs? 2.
Go ahead. This is better.
Oh no, please. Oh no, you please. Oh no. Go ahead.
I just asked. So in terms of what, being worried that it's going to be cloudy or whatever, especially with a huge band of, scientists across the country, don't we have enough technology to like seed the clouds and like make it rain right beforehand? So
yeah, so the question is, don't we have the technology to seed the clouds and make it rain beforehand so that they guarantee clear skies? Well, boy, that's terraforming on a scale that I don't think has been tried, let alone for an eclipse. What we do have the technology for, however, is that our weather forecasting has gotten pretty good. And so if you're someplace and you're mobile enough, like the weather forecast, say 3 days out, 2 days out, are plenty good enough to let you know if you're like in the ballpark or if you need to get in your car and drive like a bat down the interstate to try to find someplace that's clear. Next week, did you have a question?
Well, this is probably a really stupid question.
There are no stupid questions.
Okay, well, so you mentioned the birds and the light and the people. What about tides when it all lines up? Does water change?
Oh, that's a great question. No, the tides are normal. That is to say, when there is a tide at a full or a new moon, the tides are stronger than usual. But any new moon or full moon will have about the same tides. And so consequently, that's not going to be that big a deal. Here's a trick question for you. If there were no moon, would we have tides? If there were no moon, would we have tides? Who says yes, we'd have tides? Who says no, we wouldn't have tides? No. We would still have tides. The sun is responsible for about 1/3 of the height of the tides that we have. It's the moon that's more. So, great question. Thank you. I didn't set that up. Go ahead.
What's the best kind of telescope that you can carry with you when you go to look at the...
Okay, great. So the question is, what's the best kind of telescope to take? What I would take is a small refracting telescope. Very commonly, you can buy telescopes with an aperture that is a diameter of 80 millimeters. That's about 3 inches. They're about this big around. They're about this long. They would fit in and some of them are light enough that you can actually attach them to the top of a photo tripod, right? Maybe a tripod that has little controls that allow you to move it slowly. So that's not a very complicated telescope at all. And a telescope like that, suitable for looking at the eclipse, you can buy that for like $200. Even if you weren't starting it. If you want to talk later, I can happily give you some suggestions. I have a bunch of them in the back of my car, actually. Okay, how much more? You want to keep going?
Yeah, do we have like one last related question, or have we covered them all? Yes, sir.
Sure. So I was wondering, how much, what's the distance that the Earth can be either closer to the moon or further from the moon, where we either would or wouldn't be able to have an eclipse anymore?
Oh, that's a great question. So how far would the moon have to be away from the Earth until we would no longer have total eclipses, right? Okay. You might not know this. We were talking about tides a second ago. The moon has been robbing the Earth of energy for billions of years. And it's the tides that are at the cause of that. The moon rays and sun, but the moon raises tides on the Earth. That transfers a little bit of energy to the moon. And so every year the moon gets about that much farther away from the Earth. And it doesn't seem like much, but over 1 billion years it adds up. And conversely, the Earth is slowing down because of the energy that's being robbed from it. It's a remarkable slowdown. It's 1/100th of a second per century. But again, over time that adds up. So there was a time in the past when the moon was much, much closer and bigger and brighter. The tides were much stronger and the Earth day was much shorter, like 18 hours. And there will come a point in time, because this moon is migrating out, when it will no longer be able to cover the sun completely, no matter how close or near it is in its orbit. Fortunately, that's at least 1 billion years away. So we have another 1 billion years, so get your calendars out, mark a few dates down, right? We have plenty of time to be seeing total solar eclipses for the foreseeable future. Well, thank you all very much, Christine. Thank you for inviting me.